Hi all, welcome back to Oops with C++ session 20. In previous session we have seen how to use reference variables and how the reference variables are internally implemented, and also we have observed that reference variables are internally implemented as a constant pointers. Okay. In today's session we will see another important topic, how to pass the arguments to a function by pass call by reference method. So as previously said, in C we have only two ways to pass the arguments to functions, that is pass by value and pass by address. In C++ we have three ways: pass by value, pass by address, and third one is call by reference. Okay, just have a look out of the same program. We were discussing about the swap program. Okay, so same thing we will discuss in today's session also with call by reference method. Okay, so by using this reference variables, we can achieve call by reference method of passing arguments to the function. Okay, so for however we have used pointers for pass by address, in the same way for call by reference we are using reference variables to achieve this call by reference method. Okay, so just if you observe the syntax, just recollect the syntax how we have used reference variables. So assume you have any variable like this: data type variable equals to value, and this variable is holding some value. Now what I want to do is I have to give one reference name to this variable. Then the syntax will be like this: data type reference. Here it is not an address operator, it is a reference operator. We can call it as a reference operator. So this address of operator, again we can say it's some polymorphic behavior. In case of pointers, it is coming right hand side. Then this address of operator is behaving like a this ampersand operator is behaving like an address of operator, but here it is behaving like a reference operator. So this ampersand symbol is also behaving a polymorphic behavior. Okay, so now data type reference operator reference variable equals to variable. Now this reference variable is referring to this variable, and internally, as we have already discussed, these are implemented as a constant pointers. Okay, now in case of function call, what you have to do is you have to pass the this variable only. So whatever we have seen, right? So if you have taken this syntax, whatever is there in the right hand side, that has to be present in the function call, and whatever is syntax is there in left hand side, that has to be present in the um, that has to be present in function definition. So here I have given pointer variable, just modifying this one. It is not ptr variable. What we have given here is a reference variable, right? Okay, reference variable. Yeah. Okay. So the left hand side, so here whatever is there, that has to be present in function definition argument or function definition. So data type reference variable, that has to be present in function definition. So whereas whatever is there in right hand side syntax, that has to be present in function call argument. Okay, remember this one: function definition argument equals to function call arguments. So what should be present in function definition and what should be present in function call. Okay, so this is the syntax how to do the call by reference. Okay, now so we have this is based on the previous syntax. We have given in the function definition, we have given the left hand side syntax of reference variable, that is int reference, and here also int reference x, int reference y. In function call, the variable value variable we are passing. Just have a look once again here. So in the function definition, data type reference name means int reference variable, and here that variable name. Okay, so like this: int reference x, int reference y, a, b we are calling. Okay, now just observe this program how it is working. Okay, go with. Still, we are in procedural approach of C++. We have not yet started the object-oriented approach. Once we complete this procedural approach, then only we'll move to object-oriented approach of C++. Okay, call by reference dot cpp. So same program, void swap int reference here. Okay, and void int reference in the function definition argument. Okay, so now here int a equals to 10, b equals to 20, cout a comma a and b. Okay, now we are passing swap a comma b. Okay, so cout after swap and this one. Let's see whether it is giving proper value or not. So what we are expecting, if it is properly working, first we have to get a equals a value 1020. After swap, here we have to get 2010, and in function also we have to get 2010. Okay, yes, it's compiled successfully. Okay, 1020 in function, 2010 after swap, 2010. So it's working fine. Okay, it's doing the proper task. Okay, now let's analyze this program. Okay, so when I have this in main, whenever the CPU controller is executing this program, it comes to the main function. So int a equals to 10, b equals to 20. In that case, for this main, one stack frame will be created, and in that stack frame, for the values for a and b will be allocated. Okay, so for a and b, the values are allocated. Now assume a is present at the memory location 1000 and the value is 20, and b is present at the memory location 1004 and the value is 20. Now what I'm doing is see out a b value. What is the a value? A value is 10, b value equals to 20. That's the reason we are getting 10 and 20. So now what we are doing, we are calling swap a comma b. As I already mentioned, whenever you are calling a function, a separate stack frame will be created for the function also. Okay, so on separate stack frame will be created for swap function, and now we are passing a comma b, and here reference x, reference y. As I already told you, reference variables are internally implemented as a pointers, and it will be something like const int star x equals to address of a. Now for x and y, first for x and y, there will be some 4 bytes of memory will be allocated. Okay, and x is holding the address of a and y is holding the address of b. Okay, but for us we are not passing address here, but the compiler internally converts this reference thing to constant pointers. Okay, that is the internal implementations of reference variables. That's why I told, before going to this call by reference, refer the reference variables implementation. Okay, then you can understand this easily. Okay, so now x is holding address of a and y is holding address of b. Since we are talking about reference, we can say instead of holding address, we can say x is referring to a and y is referring to b. Okay, now int temp say this now int temp one variable will be created, and here we have given temp equals to x. So and also in previous session we have seen, whenever I am using the reference variable after the declaration, and that will be replaced with star x. When if I am using temp equals to x, what will happen? It will be internally implemented as temp equals to star x. Automatic dereference will happen. So we have given temp equals to x, but compiler will convert this statement to temp equals to star x. So what is temp? This one. What is star x? Star x is nothing but x is holding address of a, that is 1000, and what is the value present in this 1000 memory location, that is 10. So 10 will be copied here. Okay. Next, x equals to y. Now the compiler will convert this is converted this statement to star x equals to star y. Okay, you have written like this, but the compiler is converted this like this. But during runtime, the your CPU is encountering this executable statement, that is star x equals to star y. What is star x? Star x is nothing but the value present at this 1000th memory location, that is this one, and value present at this y equals to 20, that will be copied here. Okay, you can see once again here. It's 10 is here. X equals to y means it will be replaced with star x equals to star y. Then whatever value is present in star y, that is 1004 memory location, that has to be copied to here. Okay. So now this one will modify to 10 to 20. Next, y equals to temp. Just how it will be replaced? It will be replaced with star y equals to temp. Then what is star y? That is star y means 1004 memory location. What is the value? That is 20. What is temp value? 10. So 10 has to be copied to this location. So it will be replaced with star y equals to temp. You can see the value 10 replaced here. Okay. And again, when I say cout x, cout y, this will actually internally cout star x and star y. What is star x and star y? Star x is nothing but 20 and star y is nothing but 10. It will print star x is 20 and star y is 10. But here we are not using star x, star y. Compiler will automatically generate that dereferencing symbol. Okay. Right. So this is how we are getting the memory. So now again what will happen is once we got the output, now the CPU control is going to hit this closing curly brace of the function. When it is hitting the closing curly brace, what will happen? So which one got the memory lost in this swap function? That is temporary variable. So first temporary variable will be removed from the stack frame, then y, then x. After that, this entire stack frame will be removed from the memory. And again, CPU control is going back to execute the next statement of this main function, that is after swap. Okay, so all this stack frame got cleared after swap. Next, what is the value of a and b? That is a equals to 20 and b equals to 10. So this is how the call by reference method will be executed. Okay, hope you have understood this one. So reference variables, you can use it. See, you can, if you ignore this first line, these statements are exactly same as pass by value method. Okay, well, that's what we have discussed. When you are using reference variables, you can use it like a normal variables. However, you are using it in a pass by value method, you can use it in the same way. Only thing you have to worry is you have to remember how to give the reference symbol here in the function declaration. You have to concentrate only here. Okay, so that's how call by reference method will work. Okay, now, so few points you have to remember. So one is call by reference is most preferable way of passing arguments to the functions. So going forward, C++ is there. C++ still we have pointers. Okay, so going forward and upward projects, oops programming, say for example, either you go with Java or C sharp. So there is no concept of pointers. They are using completely reference variables. Okay, but internally these are constant pointers that is implemented by using anyway. So whatever be the higher object oriented programming languages, they have to use the support of C++ compulsorily. So the background for the object oriented program is C++. Okay, so this is the reference variables. There is no concept of pointers in Java or C sharp. Okay, so all the reference variables only. Okay, but the syntax is different, that you can see in Java. Okay, so now call by reference is the most preferable way of passing arguments to the functions. So why it is most preferable way? Because you need not to worry about what is there in this in the function definition, where to put star, where to put a dereferencing. That confusion you need not to take. Okay, so you can use it like a normal variables. So your task will be done. Okay. Now, since reference variables are internally implemented as a constant pointers, reference variables will also require only 4 bytes of memory. So I have told that. So if you are going with the pass by value, that say for example, if you have an object of 100 bytes size, so that 100 bytes of memory has to be once again allocated in the function swap function if it is a pass by value. Since we are using a reference variable and the reference variables are internally implemented as a constant pointers, we need only 4 bytes of memory. So in this way, we are saving lot of memory. So we either with this method we can minimize stack overflow of functions. Stack overflow problem. Why stack overflow problem will come? If you are allocating lot of memory in the function stack, at some point there you will be faced with insufficient memory. Okay, so that time your stack overflow will happen. So to we can minimize that by using reference call by reference method. Okay, in function declaration or definition, what you have to do, you have to provide this syntax data type pointer variable. Say I kept it to ptr variable, so here it will be a reference variable. Okay, that doesn't matter a name. So name doesn't matter here. So what you can see is data type reference variable. The syntax has to be there in there, whereas in function call variable name has to be there, just like a pass by value. Okay, and the modification done with the reference arguments inside the function will directly affect to the caller of the function. That's what we have seen in the swap function. We have modified, we have swapped the reference variables, and that is actually affected to the main variables also, just like pass by address. Okay, so this is about call by reference method. Okay, so I'm just repeating once again points to remember. Call by reference is most preferable way of passing arguments to the functions, and since reference variables are internally implemented as a constant pointers, reference variables will also require only 4 bytes of memory. Either we are passing in a class object or structure variable as a reference, then also we need only 4 bytes of memory in function stack. Okay. With this method, we can minimize stack overflow of functions. And in function definition or declaration, the syntax has to be data type reference operator reference variable, and this syntax has to be there. Has to be there. Whereas in function call, variable name has to be there, and the modification done with the reference argument inside the function will directly affect it to the caller function arguments. And I have seen in some of the places, some people are saying, or I have seen in some places that reference variables won't get memory. That is wrong. Okay, reference variables will also get memory. Okay, but only thing is you are not able to get the address of that reference variables. Okay, because whenever you are saying address of the reference variable, then it will actually give the referred variable address. It won't give the reference variable address. So if you have come across anywhere reference variables won't get memory, that is wrong. Okay, even I have seen while taking interviews, I have seen many of the people are saying reference variables will won't get memory. That is wrong. Okay, okay. So now, so again, so if you have the variable like this, and int variable equals to 10 and int reference variable equals to variable, then again. So in the function definition, what it has to be there, left hand side whatever is there for this syntax, that has to be present here. So function definition argument it is. So in reference variable has to be present in function definition. Okay, but the right hand side whatever is there, that has to be present in function call. Okay, this is the syntax. Remember this one. So function definition argument equals to function call arguments. So this is to avoid confusion what to place in function call and what to place in function definition. If you forget where to write this reference symbol and where to whether we have to provide address here or whether to provide address of operator here, sorry, ampersand here or here, then just no, write down the syntax of the reference variable. In reference variable equals to variable, and just for your convenience, just keep one statement in your mind that function definition argument equals to function call arguments. In that case, whatever is there in left hand side, that has to be present in function definition, and whatever is there in right hand side, that has to be present in function call. Okay, so now this is about call by reference method. Okay, now small assignment, think and do. Okay, so few of the questions like, can we create a reference to an array? So try to create a reference variable to an array of four elements. Okay, try this one. Okay, just think, um, you can do it. So can we overload functions based on call by reference and pass by value? Okay, so now what I'm telling is, for this function overloading means, we have already seen we can have more than one function with the same number of with the same name, but only thing is it has to differ in terms of arguments. Now what I'm saying is, you write a swap function, and you write a swap function in two ways. One, you provide with a pass by value, and another function with call by reference. In the same program, write both pass by value, call by reference. Check whether it is working or not, and analyze if it is working, how it is working, or which function will be called. If it is not working, why it is not working. Okay. Next, what are the advantages of call by reference over pass by address method? Just compare the pass by value, pass by address way of passing the arguments to the function, and also compare the call by reference. You can easily find out what is the difference. Okay, just um, revise this, try to do this, because these are also some of the interview questions. Okay, thank you for watching.